Hello, I'm Joey Foley, Senior Sales Engineer at Yellowbrick. Today we're going to be talking about Yellowbrick's Architecture 102 course, Advanced Features. Let's jump into the slides. And today we will cover some of our most advanced features in Yellowbrick. Now all of these features are native to the product and help enable the Yellowbrick distributed cloud experience. Whether you deploy in a public or private cloud, on-premise, or even at the edge, the features and the user experience are exactly the same across any deployment. The topics I chose for this discussion are advanced security, advanced workload management, and database replication. Each of these features allow our customers to use and interact with their data in new ways and enable the Yellowbrick distributed cloud architecture. So let's explore these topics in more detail. First, advanced security. When we think of security in Yellowbrick, we think of layered and pervasive security. Now, you may have seen this slide in other presentations, and it's a great overview of all the security topics. At Yellowbrick, security is important, and security is very important to our enterprise customers. We secure the physical hardware, and security is built into all of the software and connections. We have SSL and TLS for all external connections, whether it's loading data with our wire speed application YB-Load or running BI reports. It's always secure to interact with your data with Yellowbrick. We have unique ways of protecting data in ways no one else is doing in the market, and we are able to meet the stringent security requirements of our customers in healthcare, financial services, and insurance technology sectors. So let's double click on a few of these topics. HashiCorp Vault is how we protect data at rest. We create a secure key store, and customers can have multiple keys protecting a database, so no single person can possibly unlock it. Keys can be rotated. As with all things in Yellowbrick, it's simple to use and integrate. In fact, it's two simple commands: key store setup, encryption enabled, and you have secured the physical medium. Next, it's about securing user access in Yellowbrick. We use role-based access controls. In Yellowbrick, everything in the database is an object, so granting or revoking privileges is easy. You grant or revoke to roles and provide users access to those roles. Role-based access controls can be thought of like this: access, what can the person see? Operations, what can the person read? What can the person write? Can the person create or delete files? And then sessions, how long can the person stay in the system? When will the login work? When will the login expire? As I mentioned, everything in Yellowbrick is an object. So I'm able to grant on a database, a schema, specific columns in a table. One thing that's really different in Yellowbrick is the ability to grant and revoke on encryption keys. But I'll talk more about that in a minute. We also secure the network access. So as I mentioned, SSL and TLS encryption for all clients, whether that's to our system management console, the SMC, or the Yellowbrick Manager, our client tools like YB-SQL and YB-Load, and passwords. They're all protected. Using SSL and TLS ensures that your connection between your client applications and Yellowbrick is secure, and we verify that the server is who it claims to be. Yellowbrick always recommends using a certificate from a trusted certificate authority. Here's one of the interesting things that I mentioned earlier: securing data with C.A.R.E, or column at rest encryption. Yellowbrick offers two ways to secure sensitive data beyond encrypting just the hardware. You can use functions like encrypt KS or decrypt KS to secure data, whether you're reading it through views or extracting data. These functions affect data post-write or on-read activities. But what if I wanted to secure data pre-write? Yellowbrick offers the ability to add encryption to the actual table definition in the DDL. You can then grant access to not only the table, but then the keys. And users that have access to those keys, they can actually see the data unencrypted. Data users that don't have access to the key or are not granted that key, they will not see the unencrypted data. So what's interesting about this is you can use multiple keys to secure different columns and different tables. And rather than having to build secure views or do things like that, it's just the grant and revoke of the keys that open up the possibilities for who can see what data. With advanced security features like C.A.R.E, Yellowbrick makes securing your data easy. Next topic we want to discuss is our workload management. And I believe we have one of the most advanced workload managements in the marketplace. So workload management, what is it and why do I need it? Well, workload management is about a couple different things. It's about balancing the resources in the environment to be able to apply priority to specific workloads. And it's also about the efficiency of the system, making sure that we guarantee all the resources are used and applied in the correct manner. Workload management is hard, and most vendors, they either don't offer it or it doesn't work well. In Yellowbrick, we're proud of the fact that we offer world-class workload management because what it means to you is better efficiency of the resources that you're using. Rather than paying for elasticity or needing to spin up more compute, we make the system do more with less. So workload management in Yellowbrick is made up of pools and lanes and rules. Your workload management profile can have multiple pools. Pools can be assigned to, say, a line of business or specific activities like data loading or maybe short query bias. The pools are comprised of lanes, or how many concurrent things can run. They have a set number of lanes, where each lane is reserved a set percentage of the pool, or we have a concept of flex pools, which you have a variable number of lanes depending on how it's configured. With flex pools, you can have a single lane with all the resources defined to the pool, or during terms of higher concurrency, the pool automatically balances the resources across multiple queries. And then finally, rules. Rules are what place certain workloads in the pools. Rules can be configured with a wizard or with JavaScript and give you the ability to affect queries in many different ways. So let's take a closer look at rules. So rules make workload management happen. Rules are comprised of three things: types of rules, conditions to look for, and the action to take if the conditions met. When the rule is applied, determines its type. So we can affect SQL when it's submitted to the system, or while it's being compiled, if there was an issue and the query restarted, or even if it finished. And we can even apply conditions to running queries. Next is conditions. Conditions are what we're looking for, whether that's like a long-running query or queries running at a certain time by a certain user in a certain database from a certain IP address. We can look for any of these activities as conditions. Conditions can be set on query tags or on resources being used by a query, like how much memory is needed for a query to run or how many rows will the query return. You have a lot of flexibility and can combine any number of conditions to fine-tune what you're looking for. And next is the action that we take when the condition's met, whether that's prevent certain users from running queries at a certain time, or not letting a query that has like a select star without a where clause or a limit run. It can even be rerunning a failed query and giving it more resources so it can complete. We can move running queries to other pools if they're taking too long to complete, so things don't get stacked up behind those longer running queries or queries that need a little bit more resources. And Yellowbrick has over 75 different actions that can be applied at any time a query is running. So when we put all of these things together with workload management, it looks like this. Here we can see a profile that has multiple different pools with varying number of lanes. That top pool is for CEO activities, so we can guarantee resources for when those certain types of workloads come in. We have dedicated lanes for, say, larger running queries like data science activities, dedicated lanes for loads, things like that, and then a short query bias. And when we look at all of these little dots, each one of those is a query that's been executed on the environment. So with workload management, we can pull a lot of more activity out of the resources that you have. Our last topic today is database replication. Database replication is a key feature to enabling the Yellowbrick distributed cloud architecture. What database replication really does is give you the freedom of deployment, whether that's deploying your data in a cloud or on-premise, and how your users are going to interact with it, whether it's on Yellowbrick instances or on a Kubernetes cluster living in a public cloud environment. Replication in Yellowbrick is asynchronous. Once data is committed, we replicate it. So what does Yellowbrick do when it's replicating? How does that actually happen? Well, you can think of it as kind of like a continuous backup of data. Once data is committed into the environment, that backup is moved to a remote database, and that data is then applied, and you can choose the frequency of that data movement, whether that's every 5 seconds or every 5 minutes or 5 hours even. It really protects your data. So in the event of a disaster, you can either fail over or fail back between the two different environments, but knowing that your data is protected. Further, what key feature that replication gives you is it enables deployment freedom. Whether you want to deploy at the edge and move data on a backhaul to an on-premise system or deploy into the cloud, you have the ability to choose where you want your workload to run, and it will all run on the same Yellowbrick experience. So let's look at a couple of these scenarios. Scenario 1, active passive. So what we're doing here is you can have a production workload running in a data center, and that can be replicating to a DR site. Now, again, this is configurable. It could be every 5 seconds, or it could be a longer period of time, depending on what the nature of your network and how often your data is updated. But it's not necessarily that it's just another DR data center. It could be in the Yellowbrick cloud. We have a DR service that you could replicate your on-premise data to the Yellowbrick cloud. Or maybe what you want to do is replicate certain workloads to a cloud so that other users in your organization can interrogate that data from, say, AWS or Power BI running in Azure. Let's look at another scenario. Scenario 2 here is bidirectional active passive. In this scenario, let's say we have a East Coast data center or an East Coast cloud provider and a West Coast data center, and they're each creating data, and they want data protection across these two different environments. Well, in this scenario, you could have a database A, which is sourced and being created on the East Coast, and we can replicate that data across to the West Coast data center, and you can see there's a read-only copy of that data over there. And then we'd have database B where that data is being created on the West Coast, and it's going to be replicated back to the East Coast. And so here, both sets of data are protected, and in the event of one going down, all your data is able to be accessed. And let's go through this third scenario. So we can look at this one as kind of a distributing workloads, right? So here the idea is we'd have a production hub that's creating data, and then it's pushing that out to multiple different other environments. So the database is read-only when it's replicated out. And let's say you have a scenario where you have a load balancer and you have super high concurrency and you want to make sure that you guarantee an SLA. Well, this enables that. But it's not necessarily that we're just replicating to 3 different physical systems, maybe in a single data center. You could be replicating data to the Yellowbrick cloud, and again, have database as a service offered up to your end users. Or again, let's say you want to pick your infrastructure and you want to deploy on AWS or Microsoft's cloud or Google's cloud. You have the ability to pick where you want your data to run. So let's recap the topics that we discussed today. We talked about advanced security in Yellowbrick, things like securing the physical hardware or the end user connections to the system. There's also the really unique features like C.A.R.E, the column at rest encryption, which allow you to grant or revoke access to keys, which allow users to see encrypted or unencrypted data. There's also advanced workload management, which allows you to get the most out of all the resources in the Yellowbrick system. And then finally, database replication, which really enables the Yellowbrick distributed cloud architecture. You get to decide where do you want your data and how do you want your data to be interacted with, whether that's running on Yellowbrick instances or a Yellowbrick database as a service or Kubernetes stack running in a public cloud or at the edge. Yellowbrick gives you the ultimate flexibility. I want to thank you again for joining us today for these advanced topics with Yellowbrick.